Okay, so we're in chapter 5 and we're talking. The way that this was presented for derivatives is we sort of learned the theory of derivatives, then we learned some shortcuts, and then we learned some applications. And I kind of blend it together more than the book does. And so now, in terms of integrals, we're learning the theory, and then we're going to learn some shortcuts, and then we're going to learn some applications. And actually, I'm going to jump right to some shortcuts in just a little bit. But what you really need to understand is that you need to understand that f of x is a function f prime of x is the derivative f prime of x is the derivative which gives the slope of the function f of x, and then the integral of f of x dx is the integral which gives the area under f of x. So the first derivative finds the slope of the function, the second derivative finds the curvature of the function, the integral gives the area under this function. And then the other thing that I want to do before I jump into some practical stuff is I want to say that the integral of f of x dx is equal to this capital X, f of x, and so f prime, capital F prime of x is equal to f of x dx. So the integral gives a function capital F of x whose derivative capital F prime of x is equal to f of x dx. So f of x, capital F of x, is the antiderivative of f of x dx. Okay, so what I want you guys to do is to start working backwards. So if I say y equals x, then I ask what dy dx is equal to. You should be able to answer that, and it's 1. Now if I say, what's the integral of 1 times dx, you should be able to answer that. It should be x, because this goes that way, and so that's the derivative, and so that's the derivative, so this is the antiderivative. So the derivative of x is 1, the antiderivative of 1 dx is x. Okay, and then, so all you got to do is all you have to do is, let me just go through derivatives really, really fast. So I'm going to go through really fast. pause and think about that one for a second. Okay, so there I've just gone through a whole bunch of derivatives really, really fast. And then what I'm going to do is I'm going to say that the integral of 2x dx is equal to x squared plus some unknown constant, because the derivative of this, x squared plus 3 is 2x. X squared plus 7 is 2x. So I always got to throw that unknown constant. We'll talk more about that later. Oh, that's a third. Okay, so it all looks so simple when I'm doing it. and obviously there's a lot more to it, and we're going to get into that a lot more to it. We're going to learn some methods so that if you're confronted with sort of something that's not one of these simple ones, how can you work your way back to the function that's a derivative of? How can you take the antiderivative of something just kind of by looking at it? We'll get into those methods. And so we've got chain rule, then we've got integration by substitution, which is chain rule run backwards. We got product rule, which is a derivative rule. Then we've got integration by parts, which is product rule backwards. So we've got all kinds of ways to run things backwards. But basically what I want to leave you with right now is the idea that to start off with, to take integrals, all you have to do is you have to say, what function gave rise, what function did I take the derivative of to get this function? Well, I took the derivative of x squared plus c to get 2x. Well, what function did I take the derivative of to get 20x cubed? That was 5x to the fourth plus c. And so you're just sort of thinking backwards, and that's sort of the whole point of this idea that integrals are basically antiderivatives. Sort of, mostly.